This is the basic feedback and the control structure. In the case of the control of the motor speed, where the required speed are known as a reference is either phase or mode between the phase values. The control is taken known as a regulatory control, as the axial loop allows the accurate speed control of the motor for the aforementioned saturation in spite of the change in the temperature of the pump fluid which affects the motor load. In other instances, the output C may be required to follow the changes R, which for example might be the required position movement of the robot arm. The system is then often known as a servo mechanism, and many early textbooks in the control engineering field use the word servo mechanism in their title rather than the control. So this is what the basic principle of control. So the control system needs a reference and also the measurement devices. So that the speed measures by the measurement devices compared with the reference, and the error is amplified, and that these errors are made as a controller adjust the error and its control the process. So this final value will be there, so controls are variable. So this is the basis of feedback control structure for the motor. The motor ပြထားတဲ့အချက်ရလက်ကဆိုရင်ဒီလို motor တွေကိုအခြေခံအကျဆုံးထိန်းသိမ်းတဲ့စနစ်ဖြစ်တယ်။အဲ့တော့ဘယ်လိုထိန်းသိမ်းတဲ့ချက်ဆက်မှာဆိုရင်ဒီမှာဆိုရင်တော့ပုံတွေပြုမှုထားတဲ့နော်ဒီလိုအချက်လက်ရှိတယ်အဲ့ဒါနဲ့တိုင်းတာလို့ရတဲ့အချက်လက်ကိုနှိုင်းရှင်လိုက်မယ်နှိုင်းရှင်လိုက်ပြီးတော့မှကွဲပြားခြားနားမှုပါဆိုရင်ဒါမှားယွင်းမှုရှိတယ်အဲ့ဒီမှားယွင်းမှုကိုထိန်းသိမ်းတဲ့ကိရိယာနဲ့ထိန်းသိမ်းပြီးတော့မှနော်ဒီလိုလုပ်ငန်းစဉ်တစ်ခုကိုဒါထိန်းသိမ်းမှုပြုလုပ်တယ်အဲ့ဒါကဘာလဲဆိုရင်အဓိကနော် feedback control စနစ်ဖြစ်တယ်ဒါကြောင့်မလို့ဒီလိုအပ်တဲ့နော်လေဘာမှုဆိုရင်ဒါဖြစ်တယ်ဒါဆိုရင် reference ကိုခေါ်တယ်နောက်တစ်ခါနော်ဒီလိုနောက်ဆုံးထွက်လာတဲ့အောက်ပုတ်ကြတော့ဒါ C ဖြစ်တယ်အဲ့တော့အဲ့ဒီ C ကနေပြီးတော့တိုင်းတာလို့ရရှိတဲ့အချက်ကို R နဲ့တိုင်းရှင်ပြီးတော့မှနော်ကွဲပြားခြားနားချက် E ကိုထုတ်လုပ်လိုက်တယ်ထုတ်လုပ်ပြီးတော့မှအဲ့ဒီကွဲပြားခြားနားတဲ့ E ကနေပြီးတော့ဒါထိမ့်သိမ့်မှုကိုပြုလုပ်ခြင်းဖြစ်တယ်ဒါကဘာလဲဆိုရင်ဒါ basic feedback control the basic equation for the control A YT is equal to BD is a UT so D denote as a differential operator so DYTT AD and the BD are the polynomial. So therefore that we write down the equations are AD so D power n AN minus 1 D power n minus 1 plus AN minus 2 D power n minus 2 A1 D A0. Similarly we also write down the BD equation. So this is the basis of controls equation. So this equation will be the Q and B are the coefficient. So in this case the differential equation for the control is d2y by dd square plus 4dy by dd plus 3y square to 2du by the dd plus u. So this is the basis of control equation. So in the control function, we also have to utilize the basis of controller equation. So the control the cinema swing, no, the control net but the imagine the Yiza lower day, the two imagine the swings are different imagine the Pijari. Who might be ADYD equal to BDUD, so they are saying that the tailor that an imagine the coop set out AD imagine she there, BD imagine she there, the imagine 2 by 2 by 3, told when you imagine 2 by 4 about let's say, the tailor that come out, don't they, the imagine the Pijari. So that control functions we can also have to utilize the Laplace transform. So this is a Laplace transform means that all there's a time domain, the variables can be changed to the frequency domain. So this is the Laplace transform function of the control. So the tailor when you imagine the Laplace transform the yellow yare, change no a diga tabi yeda nebio, lebamu frequency or diga tabi yeda and imagine yellow yare, fs equal to 0 to infinity, ft e power minus st ddr, but let's say the Laplace transform imagine. Maybe that's a typical representation of the Laplace transform equation and the pole and the zero representation. The pole representation that widely utilized for this control system. The tailor cinema in Laplace transform imagine you at a pole at zero, hello having imagine the Laplace transform of the yellow yala. The space representation. So this is the typical equation for the controller function. The controller function equation can also be written in the differential equation. So d2y by dd square plus 4dy by dd plus 3y equal to u. So this is the controller equation. So that equation has to be resolved. So by solving, in this case, we have to utilize the metric method. So it's a equal to the metric of the 0, 1, minus 3, minus 4, a plus 0, 1 u. This is the metric equation. By solving the metric equation, we can get the parameters for the control function. Now, the math for the straight space representation today, differential imagine a year. I differential imagine the training moves in the muscle, differential imagine bone and follow out to Yama Chede. Now, did you my dd square plus 4dy dt plus 3y equal to use it? Now, differential imagine will to the comma swing, the imagine the metric bone and a yibito royale is equal to the metric 0 1 minus 3 minus 4 8 plus 0 1 use imagine yame, jibio mati, the control function imagine the differential imagine yeme yibito metric bone and a yibio, shilling no yala today. Form equations are we write down so h beta equal to 0 1 minus 3 minus 4 h plus 0 1 u. So by solving this one, y equal to 1 0 x. Now the imagine also metric imagine shine comma swing h beta swing 0 1 minus 3 minus 4 h net 0 1 u so yame and do a shine comma 1 so 1 0 h so imagine yama. So when we are also drawing the control functions, the controllers are also utilizing the RC methods. So this is the RC methods are the kind of the controller. Those controllers are the representation by the RC method. So there will be the input, the output, and then with our R2 and C2. So this is a simple RC circuit to represent the control system and the control function. Training will send the master and the two imagine no RC no bonane tobialo yale, must import the output sheet, our R2 C1 C2 sheet. Any control function imagine RC bonan imagine, not the training will imagine you. So therefore the control function will be the input function and the output function. So this is the H by U, so input by output. That's will be the controller equation. So in this equation, you can see H1S divided by US is equal to 1 divided by S squared plus 4S plus 3. Similarly, these are YS by US equal to the 2S plus 1 divided by S squared plus 4S plus 3. So can be rewritten as YS by US equal to 2S H1S plus HDS. So this is the controller function equation can be written. The controller imagine as controller imagine who beta H1S by US when imagine H1 S by the US when imagine beta me era by let's say Yabema 1 divided by S squared plus 4S plus 3 and needed. And that's what the imagine will put the comma swing the output function level YS by US can be 2S plus 1 divided by the S squared plus 4S plus 3 so yere era swing YS by US can be 2S A1S plus H1S when imagine yero yare. Now by let's say input function the transfer function system output function transfer function system ga ne bi do the imagine ko set bi yero yara phitတယ်ဒါ control imagine ပုံစံ So that if you are rewritten YS by US equal to 2S H1S plus H1 S, in this case we write out H that equal to 0 1 minus 3 minus 4 H plus 0 1 U and Y equal to 1 2 H. This equation that you guys get it. Anyway, imagine you get a comma swing YS by US gas swing 2S A1S 2S H1S plus H2S when imagine Yame, I am the 8 beta swing 0 1 minus 3 minus 4 H plus 0 1 U and my Y equal to 0 1 2 H rate. Imagine you Yame that control function, don't imagine you shing in a bonani pit. Only we can utilize those differential equations. In the real functions, there are many control functions from so many equations have to be resolved. So the in equations are 223 and 224. This is for the metric format. That involving many equations in the control function. Now the guy you imagine the commas, you know that you imagine about Miaba, do you imagine about Miaba? Now you imagine 223 and 224 ma for the Sala to Yama metric points and the shin in the imagine a pijali. For the matrix equations we can write down the general output equations. So H beta equal to AH plus BU, the Y equal to CH this equation. The control function can also be this we can write the control function S squared plus 5F plus 6 divided by the S squared plus 4H plus 3. This is for the control function. So that control function is also 1 plus S plus 3 divided by S squared plus 4H plus 3. So in this case H beta equal to AH plus BU and the Y beta equal to CH plus DU. So this is for the control function, the typical control function equation 上的 formula。你们今有嘢咧，看嘛，主要大家攞說 x 法，所以 a 是啦 b 用咧2比到 y 是啦 c 係2嘅，所以咁啊啲都係 control function 圖 beta 咩 a square plus 5a plus 6 divided by a square plus 4a plus 3 a control function 圖 beta 咧，所以啲 control function 下嚟不如ပုံ上咧設0入嚟所1 plus a plus 3 divided by a square plus 4s plus 3然後0入嚟你們今下所以不如ပုံ上မျိုးဖြစ်တယ်所以 x 法所以 a 是啦 du plus y 啊所以 c 是啦 du 所以你們人ဖြစ်တယ်。So we also utilize this as the transfer function. If you are using the computer like a control system program to the control function, in this case our control function is gs squared to 2s plus 1 divided by s squared plus 4s plus 3. So this is for the transfer function given. So if you use that kind of transfer function, you can enter into the data into the computer control system. So the way to enter like this, numerator is a 2 divided by 1, and the denominator will be the numerator is a 2 1 because of the numerator 2s plus 1. Denominator is s squared plus 4s plus 3, so denominator will be the 1 plus 1 4 3. And G is equal to the TF, so this is the numerator and the denominator. So this kind of transfer function you can enter in the controller computerized control function solution. The computer program formula the control function the so now below program the challenge the control transfer function the GS equal to 2s plus 1 divided by s squared plus 4s plus 3 so pick it. And also in by way 2s plus 3 below 0 so numerator equal to 2, 1 လို့ရေးလို့ရမယ်ထို့အတွက်ပိုင်းခြေဖြစ်တဲ့ s square plus 4s plus 3ကိုလည်းပဲဘယ်လိုရေးလို့ရတယ်ဆိုတော့ denominator equal to 1 4 3လို့ရေးလို့ရမယ်အဲ့မှာဆိုရင် g ဒီဒါ transfer function ဖြစ်တယ်ဒါ tf အဲ့မှာ numerator နဲ့ denominator So this is for the numerator equations the transfer function the 2s plus 1 divided by the s squared plus 4s plus 3. So therefore we can write down the transfer function g equal to tf 2 1 and the 1 4 3. So this is the first bracket with the 2 1, second bracket is the 1 4 3. This including the both the numerator and the denominator transfer function. So that kind of transfer function you can utilize in the MATLAB. The MATLAB program the transfer function 2s plus 1 so numerator ရှိပြီးတော့ denominator ဆို s squared plus 4s plus 3ဖြစ်နေတယ်အဲ့ဒါဆိုရင် MATLAB မှာသုံးမယ်ဆိုရင် the transfer function နဲ့ g ဒီ tf အဲ့ဒါမှာဆိုပထမကွင်းမှာ2ရဲ့ y ရဲ့ထဲမဲ့2ရဲ့ကွင်းမှာတော့1 4 3ထဲမယ်ဒါပါလဲဆိုရင် denominator နဲ့ numerator နှစ်ခုပါနေတဲ့ဒီလို transfer function တွေအဲ့ဒါတွေကို MATLAB သုံးပြီးတော့မှ transfer function ညီမျှခြင်းကိုAnd then we also utilize the MATLAB. So we have to utilize the interconnecting the models in the MATLAB. So the MATLAB function you can see that this is the MATLAB, the transfer function, the GS. The input is the UT. It is a time domain function, and the US is the frequency domain function. Output will be the YD and the YS. So in this case, YS is equal to the G1S multiply the US. This equation can be written. So this is for the MATLAB function. So by using the MATLAB function, we write down that kind of the transfer function. The transfer function ဖြစ်နေတယ် The transfer function GS ကဆို transfer function ဖြစ်နေတယ်ပေးနေတဲ့ function ကတော့ UD နဲ့ US ကဆိုရင်ဒါ UD က time domain US ကဆို frequency domain ဖြစ်နေပြီးတော့ output ကတော့ YD နဲ့ YS ဖြစ်ကြတယ် YD ကတော့ time domain ဖြစ်ပြီးတော့ YS က frequency domain ဖြစ်တယ်ဒါဆိုရင် output ထွက်လာတဲ့ YS ဒီ GD S multiply US ဆိုတဲ့ transfer function ကိုရေးရမယ်ဒါပါလို့ဆို control မှာဝင်မဲ့ function နောက်ပြီးတော့ transfer function ရှိမယ်ထွက်လာတဲ့ function ရှိမယ်အဲ့ဒီပုံစံကိုဒီ MATLAB နဲ့ပေါ်ပြခြင်းဖြစ်တယ် In this case, we can utilize a solver as a MATLAB. G1S, G2S are two transfer functions. So in this case, after the total input is the US. The after passing through the G1S, the output will be the AS. So the AS function also passing through the G2S, so final output will be YS. So this is the series of the cascade connection of the block. In this case, are two transfer functions. The control function involving the two transfer function blocks. ဒီမှာဖော်ပြထားတာပါလဲဆိုရင်ဒီနောက်ဆုံး transfer function နှစ်ခုပါတယ် control block ဖြစ်တယ်ဒါစုစုပေါင်းဝင်လာတာဒီ US ဖြစ်တယ်ပထမ transfer function နဲ့ G1S ကိုဖြတ်တယ်နောက် H ကထွက်လာတယ်အဲဒီ H ကတော့နောက်က transfer function ဖြစ်တယ် G2S ကိုဖြတ်ပြီးတော့နောက်ဆုံး YS ကိုထွက်သွားတာဖြစ်တယ်အဲဒါမို့ဒီမှာဖော်ပြထားခြင်းဒီ transfer function နှစ်ခုပါတယ် G1S နဲ့ G2S နှစ်ခုပါတယ်ဒီ block ကိုဖော်ပြထားခြင်းဖြစ်တယ် Meantime, you can also write down the parallel. So this is the parallel function. So G1S and the G2S are the parallel. Input will be the US, and the passing through the G1S, that will output 1 will be the H1S, and output 2 is the H2S. So output 1 H1S and output 2 H2S are combined. The final output will be the YS. So this is the way. In this case, G equal to G1 plus G2. So firstly, if the CD cascade, the G1S and G2S are in CD, in this case, G equal to G1 multiplied G2. But if the G1S and G2S are in parallel, output G equal to G1 plus G2. So this is for the parallel connection of the blocks. These CD is the G1 and G2 na kuwa so yin sunset set out so now so output G1 multiplied G2 နဲ့ညီတယ်တကယ်လို့ G1 နဲ့ G2 ကဆိုရင်အပြိုင်ဆက်ထားရဆိုရင် output G1 plus G2 နဲ့ညီတယ်ဒါပုံမှန်ဖော်ပြထားခြင်းဒီဒါဝင်လာတဲ့ function ဒီ US ဖြစ်တယ် G1 နဲ့ G2S နှစ်ခုရှိတယ်ထွက်လာတဲ့ function ကတော့ H1S နဲ့ H2S ဖြစ်တယ်H1S နဲ့ H2S နှစ်ခုကဆိုရင်ပြန်လိုက်ပြီးတော့မှနောက်ဆုံးထွက်လာတာ YS ကိုထွက်လာတာဖြစ်တယ်Then you can fill the equation will be the YS is the final output, UA is the input, that equals to GS divided by 1 plus G multiplied by 8S. So this is for the equations including the feedback function. Therefore, you see the US and the G1S, G2S, the output will be the YS. So this is for the transfer function. YS divided by US equal to GS divided by 1 plus the GS multiplied by 8S. So this is a transfer function. So in this case, US is the input, and G1S and G2S are the output function. In this case, G2S is similar to the feedback output of the YS. So this transfer function denoted by the TS, when the methods command to offering the TS is T equal to feedback G, H. If the positive feedback configuration required, then the statement T equal to feedback G, H, psi. In this case, psi equal to 1. This can be used for the negative feedback with the psi equal to minus 1. Now, the US, YS got the output function, US got the transfer function, so GS divided by 1 plus GS multiplied by HS, so you imagine a 0 yard. And that's why the transfer function TD, feedback G, H, and that's a positive feedback Pona Yeda, that's way, T equal to feedback G, H, psi no 0 yard. I Poma so in the winner US Pede, I must G1S got YS got output, now your G2S got transfer function. The G2S got the feedback function. The upper let's say, the mesh them up, go middle my feedback function. This is a single force transfer function. So single force transfer function we can write down G is equal to K divided by S plus A, S plus alpha. So this is a single force transfer function. So G is equal to K divided by 1 plus ST. So in this case, K is equal to K1 divided by the A. T equal to 1 by A. So the YS is equal to K divided by S multiplied by 1 plus ST, and is also equal to K divided by S minus K divided by 1 plus ST. So this is a single force transfer function. Equation. And in my formula, imagine a single transfer by imagine GS equal to K1 divided by S plus A. Now GS is K divided by 1 plus ST. I must be K as K1 divided by A and EBO. T as 1 divided by A and E. That also transfer function YS. Now output function YST K divided by the S multiplied by 1 plus ST. And also K divided by S minus KD divided by 1 plus ST. So the YS is equal to K divided by S multiplied by 1 plus ST. So if you are factorizing that equation, then you get this K by S minus KD divided by 1 plus ST. So in this case, by using this Laplace transform, this is a Laplace transform. We have find an inverse Laplace transform. By inverse Laplace transform, the equation is expressed in the frequency domain, so we can convert it to the time domain. For the time domain, YD equal to K multiply 1 minus E bar minus D by tau. So D by T. So this equations can be done with the feedback transfer function for this, the Laplace transform. So from the frequency domain is converted to time domain. So by solving the numerical value for the YD equal to the 0.632K multiplied dy 0 divided dt, in this case Y5 equals 0.993K. ဒီညီမကြီးကပါလို့ဆိုရင် ys ကဆိုရင် k divided by s multiply 1 plus sc ဆိုတာရရှိမယ်ဒါဆိုရင်သူ့ကိုနော် factorize လုပ်လိုက်တယ်စာကိုရင်ခွဲလိုက်တဲ့အခါမှာဆိုရင် k by s minus kt divided by 1 plus st ဆိုတာရမှာဖြစ်တယ်ဒါပါလဲဆိုရင်ဒီ transfer function ညီမချင်းရှိတယ်ဒီ transfer function ဟာဆိုရင်တော့ frequency domain ကရှိနေတာသူ့ကို time domain ပြောင်းလိုက်တဲ့အခါမှာဆိုရင်တော့ yd equal to k multiply 1 minus e power minus t divided by capital T ဆိုညီမချင်းကိုရမှာဖြစ်တယ်ဒါပါလဲဆိုရင် time domain ပြောင်းလိုက်တဲ့အခါ transfer function ညီမချင်းဖြစ်တယ်အဲ့ဒီ time domain ပြောင်းတဲ့ transfer function ညီမချင်းမှာဆိုဥပမာအပြင် yd are 0.632k multiply dy 0 by dt ဖြစ်ခဲ့တဲ့ဆိုရင်အဲ့မှာ y5 d ဆို0.993k ကိုရမှာဖြစ်တယ်